So what I was wanting to talk about here is this concept. It's floated around in the community before. It's often referred to as honeycomb. And the idea is pretty straightforward. Right now, the model that we have in OpenDaylight for the controller is that you have ODL. It lives somewhere up. Do I have a shape for clouds? There we go. So somewhere up in the cloud, you have OpenDaylight. And then you have a bunch of servers. Server switches. I'm mostly going to talk about servers here that live down in the world and are managed by OpenDaylight. And that's kind of the traditional controller model. The big brain in the sky, the devices under management that are out there in the world. And this can do a lot of stuff for you, right? And in particular, if you're trying to do something where you're doing a broad global coordination, where you're proactively poking the servers, it can actually be really good. And this is sort of the classic OpenFlow model. But one of the tricks with this is primarily works best in situations where you can minimize entirely the packet-ins that you receive. Because it turns out that packet-in leaving the box has a lot of undesirable characteristics. And there are some places where it is actually what you want, but often it's just a problem. And you can see this in the way the industry is trending. There's an increasing trend towards people putting things that actually deal with packet-in out on the box. And so what I'm kind of suggesting is, with Honeycomb, is effectively the following, which is you probably still have a global OpenDaylight instance in the sky, but now instead of having a server switch where you're just talking whatever protocol to it, server or switch where you're just talking some protocol to it. Let me change the color here. Instead, what you do is, we want this to go up to the top. My arrow is so not cooperative. So instead what you do is you actually put an ODL instance down on the box to deal with that, whatever is going to be dealt with locally. And then you might have ways in which your ODL in the sky is talking to the ODL on the box. Let me give you a concrete example. Right? Say I have an application that is going to be doing packet in is going to come in. It's going to look up some mapping that tells you what tunnel you should put that packet in onto, right? Fairly straightforward thing. But you don't want to have to be sending packet ins all the way up to the sky. It has nasty performance characteristics for everyone, increases the latency with which things happen. Not really what you want. So instead, you put an ODL instance, which has all the goodies and all the Lego blocks that we have, down onto the server. Let it manage the OVS switch and receive the packet ins as you go. And so it does that piece. And then the question becomes, how do you want the big global information to get down to it? And you actually have a bunch of different options there. I've had people suggest that you actually just make the honeycomb, the agent on the server, part of the cluster. And if you do that, then it's part of the big set of data and RPCs and everything else that's being managed by our clustering technology. I've had people suggest that you just we have a netconf northbound here, so you could expose the whole MD-Sal via netconf. You have a netconf southbound. I should not gesture at my own monitor. In the cloud, you have netconf southbound. Down on the server with ODL, you have netconf northbound. So you can just netconf mount the honeycomb agent into the big brain in the sky. That's another way you can do it. We have Pratibhan here who's working on AMQP bindings. When we have that, you can actually do federation across a messaging bus, if that's how you'd actually like to handle these things. And of course, you can use any standard protocol. So you could use the list mapping protocol. We have a BGP speaker in OpenDaylight. So you have all these other ways to communicate with not only OpenDaylight, but other control planes in the sky. that are available to you. Now, this is just one example of the cool stuff you can do with OpenDaylight. It has the other nice advantage of, how many folks here have ever dev stacked? Have you ever stacked with DevStack? How long did that take? Right. So this is what installing OpenDaylight is like on a server. Do you have a JDK? Yes, no. If you don't have a JDK, apt-get or yum your JDK. Download, unzip, run. So it's like a 5-minute process to get OpenDaylight going. Simple as hell. So it has that advantage as well, in addition to all the many tools we bring with it. And so what I was hoping to do here, actually, is to brainstorm with folks other kinds of applications we could use with this Honeycomb concept that we could do either better by using Honeycomb than we can do with the controller in the sky, or that aren't even doable from the controller in the sky that would be really interesting and cool to do here. And particularly for those of you who currently participate in projects, being able to do that. Like, you could imagine things around, like, being able to get better telemetry for the system, being able to get a better idea of the capabilities of the system. You know, all these kinds of things become doable in the context of Honeycomb in a way that is much simpler and more straightforward than if you've got just the controller in the sky. So we have mics. I want to pass them around the room, and I'd really like just to get either A, questions, or I'm actually far more interested in ideas. So just because I give you a mic doesn't mean you have to use it, but do pass it around. Awesome.
So just trying to understand what exactly are we trying to solve here? We're trying to solve the master-slave mechanism, or what are we trying to achieve here?
Not necessarily the master-slave mechanism. You could even imagine having an ODL agent on the server that is just autonomously doing the thing it does. You know, so just as an example, if I jump, how many people here know what Lisp is? I know you guys do in the back table. So Lisp is just a very basic thing that allows you to take a key like a destination IP and look up a mapping so you know what tunnel to put it on, right? Standard protocol, deployed all over the place. You could imagine having a Lisp XTR that's completely autonomous, right? That lives locally, but you get the optimization there of not having to bounce packet in up to the sky, which improves radically scalability, which improves radically latency. You could imagine a situation where I decide I want to do segment routing all the way down to the server. So I can put something with a BGP speaker there. It can learn routes via BGP. It can use that at very fine granularity to decide what kinds of decisions it wants to make about, for example, putting packets onto tunnels. So there are examples where you can have autonomous behavior, so it's not strictly master-slave. The real question is, if you want that honeycomb to be part of the bigger brain in the sky, what are the options for doing that? And there are several depending on what your use cases are. Take the mic, because nobody hears you without the mic.
Okay, so about 15 years ago, I stumbled on this architecture called distributed autonomous agent architecture, right? And it plainly describes how to handle such architectures, and it lays everything that I think we would want in OpenDaylight. So in high level, it states that you have those tiny agents, right, that you can load with different kind of services, right? For in our case, it can be the Carafe container, right? Mm-hmm. You have the Carafe container, and you load tiny kind of services. One of those services is a kind of transport, right? Mm-hmm. So you visualize the, today we use switches to switch between hardware and Ethernet packets, right? Mm-hmm. But you can also implement a switch that switches ODL packets, right? And mm-hmm. you can have those not a master slaves kind of a relation. You can have a community relation, like mm-hmm. the servers can communicate with each other, and and do some kind of processing that in maybe old times you would do in ODL, but now you can do that directly on the servers between themselves.
No, absolutely. So I mean, I'll give you an example. Like, so first of all,
I have
like,
an example.
oh, okay, sorry. I mean, within the
Okay,
context
so
of ODL, right?
A great example for something that you can do on the servers and not in ODL is calculate topology, right? For example, today, I'm guessing, I don't know that exactly. I'm guessing that BGP topology is calculated by retrieving the BGP table or whatever is there, and then comparing A side to Z side on different on two tables and determining that one is connected to the other. Everything is done on ODL node, right? Let's say that you have a small agent on each one of the devices. They can share and report directly to ODL that they are which ones of the other servers is already their adjacents. So there's no computing in ODL, just managing the data, right? ODL gets the digested data of what is connected to what.
That's certainly a doable thing. So the thing I was saying about an example is we already have in OpenDaylight the routed RPC concept. So for those of you who don't know, when I have an RPC in OpenDaylight, a remote procedure call, it can either be global, meaning that there's only one provider providing it at any given moment, or it can be routed. And if it's routed, what that means is that part of the function call for the RPC is a context for that RPC. And different providers can register implementations for particular contexts. So if you are clustered, this actually works clustered. So one of the things you could imagine, for example, is if I had an ODL down on the server, and it's part of the cluster of all the ODL pieces, including the guy in the sky, all the ODL nodes, and I want to program OpenFlow. That information is currently being routed by routed RPCs, and so wherever the call is made to request a flow be programmed for that server, that gets routed over OpenDaylight down to the server to the agent on the box, and it does the flow programming there locally. So that's an example, not the only example. As I said, you've got a bunch of options. That's the option that says, let's just cluster all the agents we have in the server into the big cluster. So that's absolutely true, that you can do that kind of thing.
Yeah, I would add if we could do inside the cluster some kind of aggregations, because, you know, if you have one ODL, big ODL in the sky and 100 switches, or 100 small ODL instances, this will work. On 1,000, it might work. On 100,000, it won't work, right?
No, I understand. There's a scaling issue to be solved for having them all be part of one cluster. That's why I pointed out that there are other options for having them communicate. The other thing I want to be really, really clear about is that there is no rocket science here, right? This is not even a novel idea. This kind of stuff has been done all kinds of times. As you mentioned, you ran into this 15 years ago. But it's not something we do now, currently in OpenDaylight. And what I really wanted to do was having a conversation about how we think about what's possible with OpenDaylight. And also to gather the cool ideas for things you guys think you can do with it.
So it would seem that having the local agent ODL be a part of a cluster is not worth the trouble. You know, I would think they should be standalone, because having them, you know, possibly sharing processing with the ODL in the cloud, that would make it a little less predictable. I mean, I think you want to ensure that, you know, any local traffic is just going to that local ODL agent. So I guess I don't see the benefit of having the local agent be part of a cluster, especially for a large number of switches.
It kind of depends on what else you're doing and how the clustering evolves. So I sadly have not had time to go hang out with Moise and the clustering guys this particular summit. I've been doing a lot of other things. But one of the conversations that's been had around clustering in the past is this notion of microshards. And so dynamic microsharding, so having very small shards that you can dynamically place where is intelligent. So if in fact you wind up with the data shards that you're usually using actually having their shard master on the instance that's in the server, And if that's the case, then what you get basically is 90% of the time you're getting local access if you're doing something on the box. If the box has a catastrophic death and comes back, then if you need to, you can get from your replicas the data that you had for that box. And that data is available and readable for if someone needs to sort of poke and grab at it from far away. So you may entirely be correct that it doesn't end up making sense at the end of the day, but there are at least some stories where you can get nice performance characteristics with a local agent and do interesting things with it while still having it be part of a more global cluster. Does that make sense?
I understand. I don't believe it, but
You don't have to. I mean, the whole point here is to have this is not a one true way approach to the problem. This is you can at least imagine this set of possibilities. I know there were other folks.
So one more word. So Cisco is building those large devices, right? And they put in Linux box on those devices. And I think putting ODL on those devices is what they intend to do maybe in the future. So they're really looking for something like that.
Yeah, I mean, it would certainly be possible to do Honeycomb onto embedded devices as well, so long as you have support for a JVM. One of the nice things about our portability story is that basically, so long as you have support for a JVM, and most things do, you can run OpenDaylight all over the place. I mean, we've seen people run it on ARM, we've seen people run it on Edison, we've seen people run it on a wide variety of platforms. And while you sometimes have to do some things to scale down, in terms of you may have too big a zip file if you're on a really small box. So you need to rebuild with just the jars in place that you need. Or you need to be judicious about which features you install and what you do with them because of memory footprint. Because we can get to a very small memory footprint if you're doing relatively well-scoped things. But if you just try and load it up with 1 million BGP routes locally, you naturally use the kind of memory that you use when you do that. So one could, in fact, put Honeycomb onto an embedded device. There's no reason not. So I know there were other folks. If we could circulate the mics a bit. You were so patient.
Hi. One of the things I'm thinking right now, ODL, my mind is ODL has a lot of potentiality, right? And everybody try to put something on that one. Now, and it is well known that it can go any side you wanted to divert that one. But the question is, in a one server, how many interface you wanted to put?
How many what?
One server, how many interface you wanted to put on that server?
How many features?
Yes.
Yeah, I mean, that I agree.
One question, because let's say that we primarily focus on service provider point of view, although I'm not a service provider, point of view, they are very much interested for the server and switch. Now somebody came in and said that, hey, I am very much interested on top of it. I wanted to put the bandwidth utilization and the quash on that one. So now question is that one server, are we going to limit in a long term or are we leave it open? Because it's a computing issue, right?
Yeah, no, but the thing is, we actually have a really good story around this in OpenDaylight. Because when we build that OpenDaylight zip file, it's a couple hundred megabytes of disk space that it consumes in terms of size. And when you start it, we don't make any a priori decisions for you about what features you want to load. Because we don't actually know. We tried this when we originally shipped in Hydrogen. We tried having release editions. And what basically came back to us from almost everybody was, you're really bad at this, don't do that again. Because no one actually got what they wanted out of the release editions, where we sort of tried to stand it up and have it running a set of stuff at the beginning. We're really bad at predicting the really cool and interesting combinations of things that people will try and do within a single OpenDaylight instance. And so when you get to the question of like how much you can load up into a server, the actual disk space that the jars consume is so trivial that in a non-embedded space, it's who cares, right? And then you get to the question of what features you choose to run. and there's sort of a presumption that you are only choosing to run features that do something useful for you. And so the amount of stuff that is actually going on in a running OpenDaylight instance is basically bounded by what is useful for a single OpenDaylight instance to do. And this kind of scaling out by distributing agents, having some brains in the sky, actually puts you in a better position in that regard. Because it might be, you could imagine a deployment scenario where the actual behavior of programming flows is being handled by local agents down in the box, and you are just dealing with the places, the things that would run globally would be things like mapping services, things like the applications that can take some global knowledge to poke the agents to tell them to behave slightly differently. Those kinds of things. And in that environment, you might have, in any given runtime instance of ODL, you might have fewer features running because you distributed those features across multiple instances. Does that make sense? Cool. I know there's more out there. I saw the hands.
So you said that one of the advantage of ODL is how easy it is to deploy.
Yes.
Right? With this kind of where you are having multiple instances running on all the servers and switches, you are again complicating that. So I can see the performance improvement that we may get with this kind of design, but then we are complicating and making it harder to deploy ODL.
So you kind of run into two things. Anytime you have something that you're managing from the big brain in the sky. Well, so let's start with just getting it on the server, right? If you just want to get it on the server, because it's a download, unzip, run, you should be able to, and I'm talking a little out of school here because Daniel Farrell's the packaging expert, not me, but you should be able to build an RPM or a deb file for installing the ODL distribution because it's not rocket science. That just depends on the JVM. So now getting it is as simple as an apt-get once you get into the distributions, or a yum. So that part of actually getting it onto the server is very straightforward. It's way more straightforward than things like OpenStack, which people deploy all the time. And then the question becomes, if you're going to communicate with the big brain in the sky, how do you set up that connection? And the truth of the matter is, anytime you have something that is going to be talked to by the controller, whether it's an OpenFlow switch or it's it's an OVS instance talking OVSDB or any of that, you either have to do discovery of some kind or that box has to be configured to talk to the controller. So the space of stuff you would have to do to point the agent to the controller is precisely the same. It's the same order as anything you would do to make sure that that box in any other way is manageable by OpenDaylight. So I don't think it actually adds any substantial new complexity to the system. It just takes existing stuff that you're doing and does logically the same thing just to the agent instead of to other things living on the box. Does that make sense? Cool.
And the other thing is when I'm looking at it, it reminds me of the oven architecture. It's pretty similar to...
Oh, yeah, no. I mean, ask around. I've been talking about Honeycomb for 2 years. The oven architecture was kind of interesting because it was sort of admission by very, very, very OpenFlow purists that, gee, maybe packet-in shouldn't leave the box. Implicit admission. But yeah, no. I mean, we've been talking about this in OpenDaylight for years. It's just looking around as we looked at the layer approach and some of the things you want to do with overlay layer, it got to be a really compelling story. We had other folks. Yep, grab the mic.
In addition to kind of brain in the sky and endpoint on the server, there are actually kind of fabric-like architectures, and distributed switches like Nexus 1000 is probably a good example. When a distributed switch manages cluster or several servers. So do you see kind of three-tier architecture for ODL?
Very, very well could be. I mean, one of the things that I've done a lot of work. I did a lot of work on the OpenFlow plugin. I've done a lot of work using the OpenFlow plugin. And one of the things you learn very quickly is flow-by-flow programming is pretty miserable. It's not fun. But you could imagine having a situation where you have a semantic model of what you want for your application that lives on the switch, the server. And that model is something that becomes available via netconf from the device for whatever application you wrote. One of the nice things about OpenDaylight is we're a totally open access regime. You can do all the things you want to do without stepping on other people. Nobody's going to tell you no. You know, it's very modular, so it's very easy for people to do their own thing. So you could have some model for your distributed switch that exposes the semantics of what you want a distributed switch. I mean, just to take a bone stupid example, like you get people who talk about, I know where all the MAC addresses are, why do I need ARP? I should just have local ARP response. So imagine you just keep an ARP table semantically here so that it does local ARP response instead of broadcasting across your network. Not a sexy example, but it's reasonable. So you can imagine just poking the ARP table semantically over netconf down from the sky to that box. So your inventory system tells ODL, here's where all the things are. That translates down to something that pokes an ARP table down to the local server switch, and then it does whatever it's going to do in terms of flow programming onto OVS. So at that point, you know, that becomes a thing, and you might also want to know, if you're operating a network in this fashion, if you actually get an ARP you're not expecting. Because if you believe that you know where every freaking MAC address in your system is, and an ARP comes in that you're not expecting, that's bad. So you could also keep a table there of unknowns, and you can decide as an application how you're going to deal with that. So you're able to break down higher level semantics for distributed switching rather than having to try and deal with flows and packet-ins all the way up in the sky. It's sort of like any good abstraction, you go through a hierarchy of abstraction as you go down, rather than having to deal with assembly language at all levels. Other stuff, I did see other hands out there, so raise your hand, we'll get a mic to you. So do people have other ideas of the cool stuff you could do with this? Because there's actually a lot of possibility here. Really? No ideas? You disappoint me. Okay, pass the mic. We got one. We got two.
One thing I'd want to make sure that you can do is to be able to measure. So I'd like to, in a network, arrange customarily. I'd want you to be able to measure particular flows, and then after you put your Honeycomb agents in place, be able to measure the same thing. So you can't assume it's going to improve something. So it may be a challenge to try to measure the correct thing. So you have to plan it in advance to make sure that.
So are you talking about measuring in an operational sense, or measuring in a is this a good idea sense?
Not just measuring overall performance, but focusing on particular flows and verifying that you're actually making a difference.
I mean, one of the things that actually is nice about the netconf mount mechanism is that if you have a flow table living, let's say we don't do the clustered example, which you could always do the clustered example. But let's say you have a flow table that lives down on OpenDaylight on the server. You can mount that into the big brain in the sky if you would like to have access to looking at the stats that are accumulated for that flow table. So that information, the lovely thing is you can, with any number of mechanisms, mounting with netconf, federating across the AMQP, actually being part of the cluster, you have the ability to have access to the information that you need from the local agent from the global brain in the sky. So you could imagine operationally something where you're trying to correlate across many things to figure out where something is breaking down. So something that's giving you automatic hinting for troubleshooting. So you observe an event in the network where you know something bad has happened, and you have something that's automatically trying to correlate the things that you think may be related to that. So you could still do that kind of a global operation in this model. You would just have to make a decision about the mechanism you were going to use to get the data from the agent to the global side.
Okay.
Make sense?
Well enough.
Awesome. So we had a couple things over here.
Okay, so the first point that I occurred to me was based on the Huawei sessions that I heard the other day about USC. Because they're doing this. Now, they're not calling it an OpenDaylight agent. You know, they're calling it a USC agent.
Sure.
But they're actually, you know, that's part of their model, right? Is that
Are they building it out of the OpenDaylight components, or is it something else?
Well, it's a piece of software that they're building as part of that USC infrastructure, as I understand it. I don't mean to be speaking for them, so if they're here, then they should pipe in. But their architecture diagram shows an agent running on the switch components also.
Yep.
Now, the way that they describe it is as sort of a muxing service, right? Where instead of running, now this is one of the things that occurs to me that's both good and bad about this,
Sure.
right? Is that, the ICD is what concerns me, right? So, just the ICD of communication between the controller.
Could you acronym expand ICD?
Interface control document.
Okay.
So
yes.
this is basically the specification of your communication protocol at layer 7, right? That you're using between an agent and the controller. I can see that getting out of control very quickly.
We have some things that make that easier for us. Because we are model driven, and thus you are modeling everything. What you have basically is you already have the model that describes that interface. And you have a number of different ways that you can, from a binding point of view, access that. So you can access it right now with netconf and restconf. Shortly, you'll be able to access it via AMQP. And so intrinsic to writing the application is you get for free, because it's how you write the application with models, you get for free this interface specification.
Well, no, what I mean is that what I've seen happen in other systems where I've been involved with this is that when you have lots and lots of different contributors who are building different types of valid data exchanges, what happens is that you get this thing. There are different terms for it, but you can call it bloat. You can call it just runaway models.
Yep.
The problem is that now that you can have 50, 75, 100 different data exchange models that are all supported through this interface. And so the problem is trying to keep track of everything. What is everybody doing? You run into overlap. It can get very messy.
Oh, I believe you. I mean, one of the things that we spend a lot of energy on is trying to talk to each other to see if we can find commonalities that can be split out as common things.
Right.
That said, there's additionally, as I said, some protection for that in the form of the fact that the only models that are going to be exposed are the ones that are brought in by the features that you're running on that particular instance of OpenDaylight. Those are the only models that are going to wind up being exposed. So if there are 100 different models available, but I'm running 2 features, I get the models for those 2 features as my interface there. The other thing that's kind of nice, particularly about netconf, is OpenDaylight can dynamically discover those models. So the controller in the sky literally gets the addition of those 2 models from the act of connecting to that local switch.
Right.
So
I mean, the upside to this, from my perspective, is that, I mean, and again, this is sort of assuming a little bit, but the point is that you're going to have, or would you envision in this kind of a case, an agent instance for a Linux server and another agent instance for a Cisco iOS device? I mean, would you imagine those being different baselines, or are you envisioning that this is the same baseline that can go on whatever kind of device it is?
So I'll give the glib answer, and then we'll sort of go to the nuts and bolts, right? The glib answer is, yeah, it's the same freaking zip file. It's just a question of which features you turn on, right? Now, that glib answer is presuming a server where a few hundred meg of storage is not a big deal, right? Which on a server usually isn't a big deal. If you start getting into actually embedding a Honeycomb into a device, you might, as I said, want to put that zip file on a diet where only the jars that are going to be part of the features you're running are present in it. That's actually mechanically very easy to do in OpenDaylight. It just wouldn't be precisely the zip that we're currently shipping. But yeah, what I do envision is you have the option of having an agent on a server. It becomes a doable thing to put an agent on an embedded device. And so you can have effectively the same running code. Let's just put aside the putting a jar zip file on a diet argument. Let's just say you have a feature you want to run, and you want to run it on an embedded device, you want to run it on a server, or maybe you want to run it up in the sky. Same freaking code. Same binary code. Not just even source, binaries. Same jar files.
Now, the other thing that I think is appealing about this, just from an infrastructure perspective, is that you're basically talking about one channel of communication, presumably. I mean, I suppose you could have more, depending on...
The world is a perverse place.
It can be. But, I mean, the thing is that this is, I mean, instead of having to open up a communication channel for 5, 10 different protocols, you basically can use this as a muxing transfer service where you just have to open up one port in a firewall or something like that in order to turn the service on, as opposed to turning on 15.
And not just a muxing service, but a muxing service where you have the potential for, and you actually have the reality of, a huge amount of performance optimization. So I'll give you an example. When you model things in OpenDaylight, they get exposed via REST-conf. So you automatically get a REST API. What is less known and less understood, because there's no reason for you to generally know it, is that a huge amount of work has gone into the optimizations in REST-conf to give you really high performance by streaming things with relatively low footprints, and to allow really strong batching behavior from REST-conf to the various other things in OpenDaylight. So effectively, not only do you get a muxing behavior, but you get a highly optimized muxing behavior, where if I were just manually standing up some JAXB services, I wouldn't get anything close to the performance that I get from having REST-conf against models in OpenDaylight. Does that make sense? Get a mic, man. Nobody can hear you on the video if you don't get a mic.
So one question, does OpenFlow contain something like registering for notifications like syslogs or traps?
So you mean the OpenFlow model or the OpenFlow protocol?
Protocol.
The protocol basically will send you things like packet in. It will send you some notifications for things like port updates. So it will send you some update messages for various asynchronous things that happen in the system. You can ask it to send you things like statistics. We actually have Anil. He knows way more about that than I do. He's the guy who wrote the initial stat stuff. So it can send you stuff about statistics also periodically, but it doesn't have syslog kinds of stuff that comes to you.
Okay, so next thing is not an idea of mine. I'm just describing something I saw in walking. We can do root cause analysis using that thing. So each instance on the server can collect, for example, syslogs, traps, some incidents on the box itself, right? And because we are model-driven, we can assign or somehow pass those syslogs, traps, and so on to and associate them to a model element in that ODL instance. Now, once we have that, we can have the server negotiate and find which one is the root cause for this thing. For example, let's say you have a BGP neighbor loss, right? Syslog. You get it on one machine, right? And on another machine, you get another BGP neighbor loss, and so on and so on. In one of the machines, you have a port down.
Yeah.
Right? So they can negotiate between themselves because you already have the BGP topology. They can negotiate between themselves who's got the actual major root cause of the issue that caused all those BGP neighbor loss.
The opportunity for better telemetry and thus better versions of that is tremendous. Putting in a plug for another OpenDaylight project, we have a time series data repository project that actually is set up to collect time series data of massive amounts of time series data, which you could also then feed with better telemetry from something like this. So yeah, absolutely. Do we have other folks? I think I saw other hands go up who want to talk about ideas for things you could do with the Honeycomb concept, or have questions or anything else. Come now, I know you're more creative than this. Pass a mic.
I'm not sure as of today if anybody has grabbed the running config and populate into the BGP.
Could you say that again? I didn't quite
Running config, let's say that I have a switch or router I'm running, running config. Is that there's any way that I'm not sure today that anybody has grabbed that one, populate into the flow?
So how would you translate running config into flows? That's the step I'm having trouble following.
Okay, running config, let's say that I have a 10 router or switch, right? I'm interfaced to each other. Now, when I'm extracting the data from that one, that interface A is connected to the router B, interface B, right? These are all connection is there.
Yeah, so you're extracting topology information from devices.
Yes.
Okay.
So is there is any tool or anything is there that we can do as of today? I'm not aware of it. So I'm looking for that help.
So I think what you're saying is if I can discover the topology, can I do stuff with that in terms of programming flows to get from point A to point B?
Yes.
And absolutely. We've got examples of that today in things like the L2 switch, where based upon the discovered topology, it will actually program flows for paths in the network in order to get stuff from A to B. That's the simple to understand one. At some level, you've got a lot of folks who are doing that. But the L2 topology sort of, the L2 is the non-trivial example of using topology for that. Other people tend to do overlays, which you don't have to understand the underlay topology as much.
Okay. No, the reason is that I wanted to put the GNS3 simulator where I have the Cisco router. I will config various kind of scenario and grab that information from that one to the ODL.
Yep.
And then make a tunneling out of it.
Yep.
So that's why I was wondering.
If you can get the data and you can transform it, you're good to go.
Okay, so nobody has the interpreter.
Not that I'm aware of. Nobody's doing that right now that I'm
Thank
aware
you.
of. Cool.
So question, when you say that with OpenFlow, we would get more performance and better scalability if we don't have the packet in going all the way to the sky. What is the alternative scenario or behavior that you expect? Basically, just processing the packet locally and then turn it into, not sending the packet, but sending some other form of RPC or something to the cloud to get the OpenFlow rule, or having the decision made locally?
So you could do a couple of things. One is you could have the decision made locally. That's certainly an option. So basically, let's say, for example, that you're speaking BGP all the way down to the server this way, then you have a bunch of routing tables already in present, and you can make the decision locally instead of having to bounce up to one controller in the sky. And this is like sort of scalability 101 in a sense, which is you distribute a problem over many workers. So if rather than having, let's say you have 1,000 switches that are 1,000 servers running running vSwitches, and they're going to on average produce 1,000 packet ins for some reason every second. It is, and let's say that the controller is 10 milliseconds from the switches, right? So if you're going to put it all up to the cloud, the big brain in the sky, now you're talking about 1 million packet ins per second that you're dealing with, at a minimum 10 millisecond latency just from the networking for you to get a response to those packet in requests. Now you flip this to a Honeycomb model, and now you've got 1,000 packet ins per second that each individual instance is dealing with, and you've got the latency you get from localhost, which is microseconds before it gets to the controller for processing. So you get a much higher, you get much lower latencies and much higher scalability by taking this route. Plus, you can scale out vertically horizontally across all of those different servers. Adding a new server becomes relatively straightforward. Whereas if you've ever tried to process, large numbers of packets in, now you're talking about sizing something fairly beefy as a box. So the ability to stand up more things that can process that huge number of packet ins per second, that's a much heavier operation than just, oh, I've got a new server, I've got a new local Honeycomb. Probably. Good.
Quick question. So it's not just that you don't want packet ins and maybe replace them with, a smaller message that has only some specific parameters, and then or as RPC or something like that, and then get back the rule. You want to make the decision locally, and that's the improvement we're looking for.
That's certainly one of the ways in which you could do it. You could make the
It is
decision
one of the
locally.
ways, but
Yeah.
I mean, does if you don't make the decision still locally, but you have to go to the sky to get some part of the state to make the decision, does that still help with the performance issue? So not sending the packet in, but replacing it with.
It can, depending on how you're getting some information from the sky. You could, for example, be getting something that's much higher level semantically than a flow that allows you to then make lower level decisions more readily locally. So rather than having to deal with 1,000 packet ins, you could get something that ends up being tens of requests up for data that allows you to make your decisions. So you can actually also get scalability there as well. Yes, Anil. Do grab a mic so people can hear you.
Packet in generally we take to, so that controller can make some decisions, right?
Yep.
Now the point is, if we are putting this thing into server or switches, we are assuming that this is going to take a decision.
Right, that you have an
some-
ODL instance locally on the server that's going to make a decision based on the information available
Okay,
to
now
it.
so the point is ODL takes a decision because it's a centralized place and it has a view of whole network, and based on that it takes a decision. Now, I joined a late, so I might have missed the initial slides. but
Yeah, no worries.
Yeah, so it take a decision based on the whole network. Okay, what all elements are there, what kind of routing you are doing, because we are all talking about the abstraction layer, right? We have abstraction layer, we say all the networking devices are just a bubble for us in that, and they are connected by lines, right? This is what our assumption is.
Sure.
Now the point is, if we kind of distribute it to making those kind of decisions, you have to go to a centralized entity and do that communications, right? So
Possibly.
yeah, but that will be required. It's not.
No. So let me give you an example of where that actually gets to be. Let me give you an example of where you actually can do something where they're taking advantage of centralized knowledge in a way that's going to. This actually gets also to your question, Veena. So a lot of times when you're making decisions about programming flows where you actually are looking at global vision, what you're doing is you are looking at topology information and making a path decision, right? Yep. And topologies are relatively slow changing compared to flows. So you could imagine basically distributing the topology information down to the individual nodes. They make decisions based upon that topology information that you keep updating as you learn things globally. And those decisions now can be local. So if I have a topology, say for the sake of argument that I get a topology change every 5 minutes, right? But I get millions of packets per second, right?
You get in 5 seconds. My point is, even if the topology change happens, somebody needs to take action. Now the point is, if that action got delayed, you might end up with some millisecond or a second of outage there, right?
Yeah, but here's the thing, even there, you also get the benefits of distribution. Let's say that I have a link down event in the topology, right, which comes up to the controller in the sky. The controller in the sky starts pushing the topology information down to the various agents. Now, the topology information is a much smaller set of information than the computation of and the pushing of all the flows to respond to it. As those agents get the topology change information for that link down, they can locally respond to it much faster than you can respond to it up in the sky. Because you're pushing a higher level semantic concept down to someone who can do the computations and the work of doing something that's a much more voluminous task. So rather than having to, across 1,000 switches, calculate the 1,000 in one place, the changes to the flows in 1,000 switches, and push those flows down, you push a simple set of information about the change to the topology with that link event. Basically, it's a link delete, right? Down to each of those things. So it's a very small amount of data you can push quickly that requires very little computation up in the sky. And down on the box, now we have an updated topology where you can compute the flow changes and program the flow changes much faster than you can do if you centralize it. It's a classic scale by distributing solution.
Yeah, I agree with that. So, and I totally support this one also, because I was thinking the same line that, sending everything to a controller is going to kill it. My point is, people really, my experience with the vendors is they don't really expect these many packets into it. They say, we know our network, we proactively do it.
Absolutely.
Because packet in base system is not going to scale whatever solution you do. If you are making whole system as a dynamic system, is not going to work. So it's going to be proactive plus reactive stuff, right?
Yeah, I mean, the part of the thing that drove me to bring this up again, I've brought this up a couple times before over the last couple years. And just to be clear, there's no rocket science here. The idea is not particularly original. All I'm doing is sort of like standing up and saying, hey, let's call out this 20-year-old idea because it's really cool and apply it in our situation. But part of what got me thinking about bringing it up again is that there were circumstances where two things. One is new set of problems came up where it was clear you wanted to not have to send packet into the sky, but you couldn't purely be proactive, right? You'd like to be purely proactive, you can't all the time. And the second one was that the zeitgeist seems to have shifted even in the diehard OpenFlow community, where before it was like, you should send packet into the sky, you should have some great controller processing millions of packets per second, to things that are going on now with folks like Oven, where it's like, it actually does make sense to have higher level semantics in the sky and locally do these decisions. So it was one of these things where clearly the timing has shifted and it's getting to be something that's more acceptable even to diehard OpenFlow people. And the second is, like I said, I just came across a bunch of, in my personal explorations of the world, a bunch of problems where I couldn't just be proactive, where there was a tiny amount of reactivity necessary, and it didn't look like fun to pump packet into the sky. Make sense?
So other thing is the switches, right? So this is, when you say it's a switches, this means you are going to run the instance of a ODL on the switch itself. That's what the idea is.
On the server or switch. I mean, because ODL, the lovely thing with ODL is it's very, very portable, so you can embed it easily, and it can be very, very lightweight, so you can embed it easily. I apologize. Have we hit the end of our session? I think we've hit the end of our session, and we are, so we should clear out and make room for the folks who are coming after. I'd be happy to chat with folks out in the hallway, preferably over cookies if we have them. I don't know if it's cookie time yet. But more than anything, I wanted to get people thinking about this, because honestly, the beautiful part is this is not really a change in the existing infrastructure code for OpenDaylight. The existing infrastructure code, the OpenFlow plugins, the southbounds for OVSTB, for everything else, that still works exactly the same, and you can use the same zip file we're building. But if you think a little bit about how you'd like to actually deploy your apps and the kinds of things they can do, we can do amazing shit here. And I wanted to get that out there.
I agree with that idea. Means the model is tempting, and we see that it's scalable. The only concern my side is it need to be done correctly from centralized perspective, that all the agents are kind of getting the knowledge which, from a centralized, whoever is sitting in a sky, right? So they should not be looking for, okay, what the hell I do? They should not be in a position. So
oh, no, absolutely.
So it need to be done in a correct way.
You've got to figure out how what it is you're trying to do with the agent, and if what you're trying to do requires global knowledge, you have to figure out how you're going to get it. And we'll talk in the hallway. We actually talked about the different ways you could possibly do that depending on your application earlier.
Okay.